Hello everybody, Mikael here again, and I'm going to talk to you about programming in C, and today we're going to talk about pointers, arrays and strings. And in general, it's all about how pointers works, but arrays and strings are very related, so we're going to grab them together and see what we can do with it. So the agenda is, like I said, pointers, arrays, strings. And this comes from the chapter 5 called Pointers and Arrays in the book The C Programming Language. So I'm going to try to start with one slide that sort of covers it all, if we only could understand what it's trying to tell us. A pointer, which is the main purpose of today, is a variable, and it contains the address of another variable or a storage area in memory. Okay, a pointer is an ordinary variable, but it contains an address, and this is an address to somewhere in the memory where we can store or read data. Okay, think about that for a minute while I just move on here with my slides. So I'm going to try to exemplify this with a sort of a code example, and I'm going to start by declaring two variables. So I'm declaring an integer variable first, and then I'm declaring an integer pointer, a pointer to integer, and that's also a variable, just a small different one. And on the middle line here, I'm sort of taking the p variable, and I'm assigning it the value of address A. So I'm basically putting address A, put that into the pointer. Okay, this means that now P contains the address of A, so P is actually sort of referencing the actual variable A in memory. They're basic pointing at the same place in the memory, if I say like that. And then I'm just showing off that this is true by starting to assign a value to A. I'm giving it 40. And at this stage, both A and star P are 40. And then just showing off that I can also change the exact data in the memory by using the pointer. So I'm taking the pointer here and I'm incrementing it by 2. So the value that the pointer is pointing at currently will then be 42, and that is the same place where the A variable has its storage. So that is also 42 for now. Okay, so just an example how a variable and a pointer can sort of address the same memory and change it and read its content. This is the same example program. I'm just gonna print out the values within my example program to show that it is actually correct what I'm trying to do here. So the first two lines there, they're gonna print the value of A and the value of the pointer, what it points to. So star P. So both these will print the value 42. And then I'm going to also print out the address. So I'm starting to printing out the address of variable A. And the ampersand is giving me the way to sort of access the address of A. And I'm also printing out the value of P, which should be the same as the address of A. And just to show off that the address to the P variable where it's stored in memory is also an address, so I'm going to print that out also. So let's see how this looks when I sort of actually running my small example program. So there I see that the A has the value of 42 and star P also has the value of 42 because they are referencing the same memory section. Then I see here that the ampersand A, that references that specific memory there, and that is the same memory that the P pointer is accessing. And I can also see that the P variable is stored in another place in the memory, so it's close, but it's not the same. So this is a way to sort of investigate how the pointers and address and variables relate to each other. I'm gonna do this once more, and I'm trying to create a sort of an image for you of the memory, how the memory looks like. And maybe that will sort of help in understanding or creating your own image, mental image on how the memory layout is and where the variables are stored. So I'm just for the fun having a small memory here with 8 bits. So 8 bits and the address to where these bits are stored in the memory. And like my example, I'm declaring the integer variable first, so that is placed in a position in the memory, and then I'm declaring the pointer to integer variable p, and that is also placed in memory. And for now, these two variables has uninitialized content, so the data on these memory positions is initialized. And then I start to use them. So I'm starting first to assign the address of A into P. So we can see there, the address of A, that is 2, 0, 1, 0. And we can see that the data now, that the P is sort of the data of P, sort of the content of P has now changed. So its value is now same as the address of A. So one could say that P points to A currently. And this also means that when I want to, so P points to A, but if I want to get the value that P points to, so the value of A, P points to the address of A, but I want to get that value. And then I do star P, so then I will get the value. So star P is the same as A, is the same as, well, the memory there is still uninitialized. We haven't provided a actual value to A yet, but let's do that. But they are the same, since they are sort of addressing the same part of the memory. So here we go, assigning 40 to the variable A. So now we can see that the data that A is referencing, the address of A up there, now contains the value 40. So now A is 40 and star P is 40 and A equals star P. So they are sort of pointing out the same part of memory. So they're reading the same value there. And yet another one where we go here. So I'm incrementing the value that P points to. So I'm integrating that. And that is more or less saying that A is plus equal to 2 also. So now is A is 42. And again then, A is the same as star P is the same as 42 now. Okay. I hope that somehow helps you, these two small examples on how it works. And these are basically the sort of these are the essentials of the whole slide lecture. So if you feel it's a bit fuzzy for now, well, go back and review this section again and take it a bit slow and try to understand what actually happens in that kind of example program. Maybe you could also try to sort of write your own example program here to investigate how this works with the pointer, the variable, and the address. So to sum up this far, we are working with an int a, so that was a variable, and then we have an int star p, that was an integer pointer. We got the address of the two, so both are stored in memory as variables. So when they are in memory, they have an address, so I can sort of look them up in the memory. We got a, that was a value of an integer. P, that was a value of p, so it was an address to an integer. And when we do star p, that is the value of the integer pointed to by p. It's good to get the terminology up here and running, so it's easier to sort of think in your mind when you're using these words. They might help you to sort of organize what's actually happening here. You can also see code samples that are using int star and space p or int space star p. So the two above, they are equal, and it's really a matter of taste which one you would like to use there. But be a bit, look up the last example there. So there we are actually declaring an integer pointer a. And then b, that is just an int. So that is not an integer pointer. So they are same, but not. So keep some notice on how you do your sort of, when you declare the variables. But this is how it works. So good to know. I'm going to show you a bit about how the pointers work as a function arguments and what we can do with them. So I'm trying to build a small function here to show it off, and I'm calling this function the swap function. So the intention is that I'm going to send in two arguments. So I'm going to take in two parameters here, a and b. So I'm going to send in two arguments or parameters, send in two variables, content of the variables. And I want them to change place. So, but this really doesn't work in C. So in C we have this pass by value. So when we're calling a function, it is the value is copied into the function. So when we are in the function, we can't really change the content of the variable that we are sending as a parameter into the function. So this really doesn't work. But let's see how we can make this work when we do the same thing, but we use pointers instead. And this is something that is called pass by address. And what we are doing here, that we are building the swap function to take an integer pointer instead. So we get a pointer to an integer. And when we have this pointer, we can sort of point out that part in memory and write directly into that memory and change its value. So then we're having two pointers in here. So then we are reading directly from the memory, taking that value from A, storing it in a temp. And then we are sort of reading the value from B, putting it onto sort of the memory part of A, and then we sort of assigning B with the temp value. So now we have switched the content of the sort of data cells that these two pointing out. So here we can do something. Some other programming language, they have what is called pass by reference, where you can actually change the content of the variable, but C doesn't have that. But we can do more or less the same by using pointers, and we call this pass by address. And here is the main program that we are when we are using our swap function here, and the essential part is down here in the middle. You see swap, and what we are sending into this working swap function is the address of A and the address of B. So I'm sending the memory address of these two variables into the function, and then the functions can sort of read what is in these memory address and then sort of write and read from them. Okay? Pass by address can be achieved by pointers and addresses in C. This is just showing off that it's working. So this is my small main program actually seeing that A and B has values, then I swap them, and now they have sort of swapped their values. So let's take a note on arrays. Arrays are arrays of a specific type. So we declare them with the brackets, and then we put a size in them. In general, we can also put empty brackets, but let's see how we do it with a size here. So here I'm declaring a integer fib, and I'm giving it 10 positions. So this will, we can read this as I allocate 10 integer positions in a line in the memory. So these are sort of position 1 is an integer, position 2 is an integer, position 3 is an integer, and they are stored in memory like this. I can also do like I'm doing on the second part here. The difference there is I'm just declaring a constant integer and saying, okay, I want to work with 10 here. And then I'm declaring the array as having the size then there. So that's just showing how to use a variable instead when you sort of declaring how long the array should be. This is also just an example how we are working with the individual parts of the array, how we access each element. So if we have this fib, this is really a Fibonacci sequence, and I thought I was sort of creating the first 10 values of the Fibonacci series. And I can actually do it like this. So a Fibonacci series starts with 0. So I put that in fib 0. So that is the first integer position. And then I take the second position, which is fib 1, and I place a 1 there. That is the start of the Fibonacci sequence. And then fib 2, that is the sum of fib 1 and fib 0. Oh, great. And fib 3, yeah, and that's also the sum of the two preceding numbers in the sequence. So in this way I can sort of build up the whole sequence. And still, it's an example showing how you can write to the individual parts of the array or the elements of the array, and how you also can read their values. This is another way how we can work with an array, and here we can see, well, one reason why I created this constant variable saying how long is my array. And then I'm using the variable when I declare the array. And then I can also use the same variable when I'm doing the loop and walking through all parts of the array. And that is basically because I don't like to write int fib 10. And then I have to write another 10 in the loop there. Since they are sort of, the 10s are sort of copied and paste now, and it's better programming manner if I put them into a variable, and then I get only one single place where I can change this 10 if I want to have a Fibonacci series of 5 or 15 instead. So in the loop, in the for loop, I'm just assigning the positions of the Fibonacci going from 0 up to 9 and giving them the value of that specific Fibonacci number in the sequence there. I can also do array initialization, and I can fill the array with values when I define it. So here I'm creating a Fibonacci of 7 of items, and with the curly braces I can provide values which are then stored in the memory to each position, and the position then, as you know, starts with 0 and goes up to 6 in this case. We can also see how pointers relate to arrays. So array is sort of pointing out an area in the memory where I store these types or integers in this case. But we can also use a pointer to point to that specific start of the array. And then we can have the pointer doing pointer calculation or pointer arithmetic, where I sort of walk around with my pointer in memory, pointing out the different parts of this array. Let's see what my small example here is doing. So I'm having this Fibonacci array of integers, and then I'm creating an integer pointer there. And this integer pointer, I'm assigning that to the address of the first item of the array. The first item of the array, which is fib0 then. So now I'm having that P is pointing to the start of the array. So when we look at these three last lines here, the content of P is then the same thing as fib0. That is the same thing. And then I can do arithmetics. I can calculate with my pointer, increment, decrement. So when I see that P plus 1, that is the next position in line. So it jumps one integer ahead in the memory. So in this case, that will be the exact same thing as fib1. And then when I do P plus 2, that would be the same thing as fib2. So pointers and arrays can sort of interact in accessing sort of the memory. And these pointers, well, they could be a bit, well, powerful or dangerous, but you can actually make them point out any part of the memory and you can get direct access to that part. Dangerous, powerful, yeah, you choose. Then we have something called strings, or strings are in general a character pointer, or like character array, we can even call them. So here I did two strings, and I did them first. I did them as a string array, so it's an array of characters, and then I did them as a sharp pointer, so that is a pointer to a sort of string, if we say so. So string is the same thing as an array of characters. Specific here would be when I'm dealing with strings, they always have this null terminating character, a \0, the actual value of 0, and they are ending with it. So when these strings are stored into memory, they will contain as many characters as the string obviously contains, and then +1 for the null terminating character. So they will always be null terminated with this sort of 0 at the end. This is one example how I'm using the string as a sort of array of characters. So it's declared up there, and then I'm going to loop through it, and I'm going to print out each and every character in it, and then I'm going to exit the loop. So you see I have a printf of the %c there, and I'm sort of accessing each individual element of the array there. But look also at how I constructed this for loop. You see in the middle there, where the expression is, that is sort of, if the expression is true, you continue in the loop, but when the expression is false, you will leave the loop. So this expression here is string a in bracket I. So this is basically checking the value of the current of that specific character. And if that specific character is not 0, false, then it will continue. So you see this expression will actually sort of continue to go through all the character in the array, and then it comes to the null terminating character in the end of the string, and then it's okay, here we got a 0, and that's false, so we're going to leave the loop. So this is one way to sort of go through a string until it finds its null character. And this is basically the same, I'm just doing it in another way here. So I'm having my sharp pointer instead, and I'm doing it in a while loop here. So I'm also declaring a character, and I'm going to print that character out in the loop. And I'm having this sort of expression up there that actually sort of assigning the content of string pointer to the variable ch. And then I'm incrementing the string pointer. So it looks a bit strange, but it's actually when it reaches the null terminating string, it will be sort of that ch will contain 0, and this complete expression will also be 0, and the loop will end. So this is a way to sort of loop through a string using a while loop, including an assignment of each character in the string. We can take one more minute just to check out that while condition, because maybe you thought it was a bit dense construct. You will like these dense constructs later on. But so the first one up there is equal to the second one. So here I write it a bit more explicit what's actually happening in the while loop. So I'm going through the string pointer here, character by character. So first I'm pointing out the first character here, and as long as that is not the null character, just proceed in the loop. Okay, so I go into the loop, so I assign that character to ch, then I'm going to print ch, and then I'm going to increment my pointer, so the pointer points to the next character in line, and then I go up there, and then I check, what character am I pointing out now? Is it the null character? No? Okay, continue one more and more until we reach the null character. So, yeah, look at these two. They are sort of equal, and feel free to use any one of them, but it's more sort of the essential part is to understand how we go through a string by character by character by character until it's null character, and then we use that as an expression to leave the loops. So, yeah, pointers, address, memory, arrays. Okay, so this is more than enough for today. The most important part in this whole lecture is to understand the basics of pointers, address, and how that relates to sort of a variable or a place in memory. And those were the first things we did. But let's move on to check out some of the advanced features of pointers. Yes, so we are aware of them. So we can build arrays of pointers. So an array, combinate array with a pointer, an array of pointers. So in this example here, I'm trying to build up sort of a maybe a storage area for a text editor where I save my document line by line. So this array is sort of has the size of that many lines that my document can hold, and each line is consisting of an character array here. So, and here I'm sort of also initializing this array right away with the curly braces, and then I have a comma separated list of the different arrays here, so they will get in the position 0, 1, 2, 3, 4 positions, and it's going to be 5 lines then. Okay, good. If I would like to sort of loop through this char pointer array or array of strings, I can do it like this. So I'm going line by line until the end of line, the last lines here, and I'm just going to print out each string that then goes from document 0, document 1, document 2, so each element in the document array there. And if I would execute this example program and print it out, it would look like here. So it's a small document implemented with a array of character pointers or array of strings here. Another way we can do when doing it a bit more advanced or complex would be to create the multidimensional array. It's an array of arrays. So let's create one there. So I'm creating this is a board of, well, I call it Luftfahrtschack in Swedish. I actually don't know the name in English. Luftfahrtschack. So you're gonna the game is all about getting 3 in a row, and you're playing with against one mate then. So I'm creating the board here. So it's free board, and I'm also initiating the board right away here. So you can see I have a outer curly brace, and then I have 3 curly braces within there. So I'm sort of initiating first one of the arrays, and that has sort of 3 lines, and then the other 3 arrays getting the 3 values. Okay? Let's see when I sort of start playing my game here. So I start by sort of I start with X, and I'm putting it in the center position. The center position here would be 1 1. So upmost left would be 0 0, and right bottom would be 2 2. So I start at the position 1 1. That's in the middle. So I just fill up the board with X and zeros, and then I'm gonna try to print out the board. And here I'm gonna go with a loop in a loop. So I'm gonna start walking through each line. So that is the outer loop. The outer loop takes 1 line in the board, and then I have an inner loop that is sort of taking each column of that line. Okay, so first line by line, and then column by column, and then print each character at each position there. So if I'm going to create a sort of example program for this and actually print it out, it would look like pretty much like we see here. My small game of Luftfahrtschack. That was multidimensional arrays then. Let's see another, well, we have seen initialization of pointers array, but let's go. I have another example of it. So I'm going to create a function called getMonthName. I'm going to take an integer as parameter, and it's going to return the name of the month here. And when I create this function, I'm going to store all the names of the months. I'm going to store them as strings in a character array. And I'm also going to store one extra string there that's saying this is an invalid month. So when the user sends in like a negative number or a very high number not representing a month, I need some error message to send back to him, and I'm just saying no such month. So when we execute the program, we see there how it goes. 7 is representing the month July. Okay, good to know. And we can have a look at the small example program that they made for this. So I'm just creating an integer variable, then I'm creating a sharp pointer, the holder for the result then. I'm giving a 7 to month_num, then I'm calling the getMonthName function, sending in month_num as a parameter. So the argument sent to the function will be 7 then. And I'm storing the returned result in month string, and then I'm going to print both month_num and month string, and it looks like this then. So let's see how this sort of getMonthName looks a bit like, and we're going to start checking out how I sort of initialize this pointer array here again. So I'm having a sharp pointer months, so it's an array of sharp pointers, and I'm sort of initializing it with a lot of strings here. So I'm starting with illegal month, gonna go with position 0, then I'm gonna get January, position 1, February position 2. So this is nice. I'm going to have all the valid months on the actual position in this array. So it's going to be easy for me when someone sends in integer 7 then. Yeah, I'm just going to point out months 7 and I will actually get the correct month name there. Let's check up there also that I'm using static. So I'm using the static variable class when I declare this. This means that this variable here is only initialized once. And so the first time someone called this function, get month name, the value, the content of this character array is initialized, and then it will keep its value. So static may make it keep its value, and when you call this subsequently many times, the sort of variable will hold its value and it will not need to be initialized upon each entry. Static in this context does that for us. So then we can just sort of do a ternary operator here or a conditional expression, checking that as long as the incoming I is in between 1 and 12, then we can sort of return the actual month name. But if I is outside of that, we return months in 0, saying illegal month. Good. Let's take one more of these sort of advanced one. This is about command line arguments, and this is how we can send arguments to the main function using the command line. So when we execute our program, we can actually send these sort of parameters or arguments into our program, and the program can work with them there. So this is the way we do that. First, we need to specify int main and declare that it's going to take this incoming arguments. So we declare argc, and that is an integer saying you did send this many arguments on the command line in here. Then we are going to have a sharp pointer, so an array of character pointers, and each position there will contain each argument in there. Okay, so let's see how this can look like. I'm going to build a small program here containing some logic. So I'm going to, let's see what we're doing here. So I'm checking here that argc must equal 4. And if it does not, then I'm going to print out an error message and exit with a failure status. And I'm also going to print out the message on how this is how you are supposed to call my program. You must send in the arguments lower, upper, step. So you, besides the actual program, you also must call or add, send in then 3 arguments into my programs to work with here. Okay. Let's see how we are going to use these arguments then in the complete solution here. So here I have the whole sort of main program here. It's actually, yay, it's going to print the Fahrenheit Celsius conversion table. And that's why I'm going with a lower, with a start value, an upper end value, and then the step variable. So how many rows will I going to print out in between there? So when I have checked the error part up there, so I actually getting all the arguments sent in by the command line, I can take this argument. So since these are argv1, argv2, argv3, well, the basic argv0 is up there. So that is the name of the executable. So the program I call this with, that is argv0. So the first argument then that I actually want to have here is argv1, argv2. And I need, those are strings now, so I need to convert them to an integer or whatever they are before I can work with them. In this case, it's going to be integers since that's what my function is expecting there. Maybe you want to do a bit about the error checking also when you're sort of getting these strings from arguments from the command line. Maybe you want to check that they sort of contains a valid integer also, so it's not sort of the user sending in very bad input to you want to crack your program. And so yeah, that might be a good suggestion, but we leave it for this for now. So I guess if we're gonna print that, work with this program, first I try here up. Okay, I'm executing main, I'm sending in 2 arguments. No, this is how we're gonna use it. You're gonna call main with 3 arguments. So then I try again. I'm just calling main without any arguments. Yeah, that doesn't work either. Then finally, I'm calling main with 3 arguments. So 1 would be lower, 100 there will be upper, and the step will be 25. So then I'm going to print this Fahrenheit Celsius conversion table. So it could be most useful learning how these command line arguments is sort of working and how I can sort of build smart programs by sending in arguments to it. I also want to mention, I'm not going to build an example of this. This is just for you to know that you can also have pointers to functions. A pointer to a function. Well, I can see how it looks like here. So this is an ordinary function down there. And this is how we could declare a pointer to that particular sort of function, or declare a pointer that could point to that function. So, and when we declare these function pointers, we are declaring them including their return value and including their parameter list. So that is the whole sort of type of that function pointer. This could be good to have. Perhaps you want to send these function pointers as arguments to other functions. There are such functions that are taking another function as an argument to it, and function pointer then. Or perhaps you want to store them in arrays. So could be useful thing, at least at this stage. I just wanted to let you know that you can have pointers to functions also. And there we go. This is the summary of it all. Did we get it? We did talk about pointers. Pointers, how they relate to variables and addresses. We talked about arrays, how they sort of are stored a bit in memory, and how we can use pointers to access the arrays also. We talked about strings, and strings is in general a character array, an array of characters with a null terminating byte there. So pointers, arrays, string in the same area. Yeah, and we can, to wrap this up, we can see on these 2 last examples here, because that's where we started today. So the variables in the program, they are sort of storage units which can hold values. They have a specific position in the memory that can actually hold data, a value. So in the first program there, we had the variable a. It was the same that the pointer p was pointing to, and that was the value 42 in our example program. And then we talked about variables. They are stored at an address in the memory. And we can access this address by the ampersand a, ampersand a, the same value that we put in p, the pointer variable. So they contain the same value, and that was an address into memory. Okay, so if this feels a bit fluffy, then do as I said before. Go back and watch the sort of first initial part. It's like 10 minutes. I tried to show you how the A and P works to sort of change the value, and also review the sort of memory sketch I tried to give you. And hopefully that will sort of help you in understanding how pointers works. So this was all for today. The basic idea was to learn you how pointers are sort of working. And then we got arrays, and then we got strings, and then we got some more. So I hope you enjoyed it. And as usual, you need to go to write yourself small example programs. If you don't do that, it will be very hard to get going here. And do know that these small example programs that you are writing, they are very valuable. You can go back to them. You can loan code from them and copy to your new programs. They are sort of like small bits and pieces of your knowledge base, so they can be very valuable for you. And when you're sort of creating a very large program and it's hard to debug, then you can just take that specific hard part out, put it in a small example program, and there it might be easier to debug. Okay, so thank you for now, and I'm gonna see you in another session on the C programming language. Okay, bye for now.